2.3.
Except when she talks about 8.
Polynomial functions of higher degree. Joelle. With modeling. In case y'all haven't gotten the hint at this point, it's all with modeling pretty much. Alright, so this time we're dealing with cubic functions, which are degree 3.
Is it modeling or just model?
Modeling. Oh, I was like, if that's modeling.
We just won't talk about it. And quartic functions are degree 4. We can also have a degree in polynomial.
Why?
Well, it's just like a degree 20. Like, that's what that means. Degree in polynomial. It has the form. By the time we're done with this chapter, you will be tired of writing this form out, but you'll know it. A sub n, x to the n, plus a sub n minus 1, x to the n minus 1, plus dot dot dot, plus a sub 2, x to the 2, plus a sub 1, x, plus a sub 0, given that a sub n is not equal to 0. What?
Do we have to memorize that?
Memorize it? No. Understand it? Yes.
Oh, great.
I don't
Even worse.
understand it.
Even worse.
This is just the format, like if I were to write 3x cubed plus
dot, dot, dot.
2x
What's up with the
squared
dot, dot, dot?
plus, because you don't know how many terms are missing,
Oh.
plus 5x minus 3. This is a degree 3 polynomial. I could keep going out, but if I added 10x to the 7th, this is now a degree 7 polynomial. So it's the nth degree. But see, then I have all this missing in here.
I remember this from last year.
So,
What do you mean you remember this from last year?
because I put it on the board last year.
I don't remember.
Because we had to count the degrees. I remember this. We had to count the degrees, and it was like the easiest thing on the exam. On the first.
All right, definition: the vocabulary of polynomials. Each monomial in this sum, okay, talking about the one above, a sub n, x to the n, a sub n minus 1, x to the n minus 1, dot dot dot, a sub 0 is a term of the polynomial.
I'm tired of writing that. Where's the A1 thingy? A1x. Do you not need that one here?
That's what the dot 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 is for.
So why is term highlighted? Because we need to know it.
Because that's definition.
Oh.
This is the definition of this.
I'm already tired of writing this stupid thing.
I was determined in high school. Mr. Cass made us write it so many times. Well, he would have just assumed we not write anything down. But I wrote it so many times in high school, I was convinced that when I became a teacher, I was going to make a poster for it. I just haven't done it yet. So and I wouldn't have to write it a million times. I could just be like, that thing.
Can I use the bathroom?
Sure.
Okay, but I have a quick question. Is P of x equals to that long thing not the same as what you just wrote in each polynomial?
This,
Yeah.
these are just the terms. These are just, there's commas between.
But what about the a squared? The a sub. That's why there's the dot dot dot.
Dot 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 is for. I just wasn't going to write all the terms.
Did you just put the last one in there?
Because in reality, I'd be writing a sub n minus 2, x to the n minus 2, a sub n minus 3, x to the n minus 3. If you actually wanted me to list them all, I would literally be listing every single one of them.
Okay. But it's the same thing as you just wrote up there. The last number is just a to the sub
Yes.
0, so that's.
Yeah.
She just condensed it
Alright, a polynomial function written in this way with terms in descending degree is written in standard form which is how you should always write stuff. Descending order. The constants a sub n minus 1, a sub 0 are the coefficients of the polynomial.
Is that A0?
Yeah. The term a sub n x to the n is the leading term. A sub 0 is the constant term.
So the constant's just at the end and the leading
Oh,
is
dear.
just the first term? If you really wanted
Yes.
to, could you just do A, you say sub n?
Yeah.
A sub n x n dot dot plus dot 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 a to the 0? Can you just do that?
Technically, yeah.
Like that
I
one?
mean, yeah. I mainly write it that way so you can see that it's truly in descending order.
Okay.
But yes, you can. And like a sub n is the leading coefficient, okay, if it asks for that. The degree is obviously whatever the highest power is, things like that. Alright, so I'm going to show you some rough graphs of what common cubic functions and common quartic functions look like. So first, the common cubic ones.
Wait, was there any graph? I swear there wasn't any graphs for 2, 2.
There weren't.
Okay.
Alright, so a sub 3 is greater than 0, and we're going to have for a sub 3 less than 0. So I'm going to draw 2 graphs underneath each one.
Dang it. I gotta go to the next page.
Alright, so one option, I'm not even plotting them on like an axis. I'm just going to show you what a rough sketch would look like so that if you see it, you can be like, that's cubic or that's quartic. Okay? So those are the greater than 0 ones. Less than 0. Something like that. Common quartic functions. So for a sub 4 greater than 0, and then I'll also do it for a sub 4 less than 0. Those two.
Those look weird. Like, I'm just saying. They look. No, I'm not even.
They literally are like a W.
I know, it's just weird.
Okay.
Okay.
Honestly, I'm not gonna lie, when I'm looking at it, it kind of looks like I just scribbled on my paper.
It kind of does.
Wait, are they both supposed to be a W? Or is one of them supposed to be like the first one?
This one's kind of sort of flat.
Oh, I do it
A U,
twice. On purpose.
a W.
Is it like a U and a W and then a?
Two M's.
I'm confused.
Basically 2 M's.
For the last one is 2 M's.
Basically.
One's just kind of bent and the other one's just really bent.
Basically. You good over there?
Berkeley, that's so cute. Well, not really.
But the first one is the first one supposed to be straight?
And your birthday.
Huh?
Is the first one supposed to be straight? Okay. Sorry, the other 2 were like upside down. That's why I was confused.
All right.
Are we almost done?
Definition. We have this page left.
Okay, good. That's
All right. Multiplicity of a 0 of a polynomial function if f is a polynomial function and x minus c to the m is a factor of f, but x minus c to the m plus 1 is not, then c is a 0 of multiplicity m of f. Okay, so with that, you'll have problems that'll say, like, what is the multiplicity? What is the 0? Okay, things like that. Zeros of odd and even multiplicity. All right, so if a polynomial function f has a real 0, c of odd multiplicity, then the graph of f crosses the x-axis at c0, and the value of f changes sign at x is equal to c. If a polynomial function f has a real 0, c of even multiplicity, then the graph of f does not cross the x-axis at c0, and the value of f does not change sign at x is equal to c. Alright, intermediate value theorem. Okay, we call that IVT. If A and B are real numbers with A less than B, and if F is continuous on the interval A to B, then F takes on every value between F of A and F of B if Y sub 0 is between F of A and F of B. And they have opposite signs. Then F of C is equal to 0 for some number C. In A to B. Some days it works and some days it doesn't. So. This is a very important theorem in math. Come on. Yay. Good enough. I don't care. Very important theorem in math. Make sure you know that it exists for now until we actually use it. As far as leaving space, I mean, not that we're moving on, but you'll probably need about 2 pages-ish. It's 2.5 for me, so probably 2.
Are we doing alright? Need more?
That's it.